Welcome back, guys. Today we're going to be starting into the next part of our unit, which is on absolute value. So in this section of the unit, we're going to be looking at absolute value functions and absolute value equations. Now, before we get into the functions and equations, we need to first establish what is absolute value. Now, absolute value is a concept that you may have heard about before, possibly in science, maybe in physics, but we don't really look at it too much until Math 20-1. This is also a concept that you're going to use in future courses, Math 30-1, Calculus, and so on. So let's get into just looking at the definition of absolute value. And to do that, we're going to start off just by looking at some examples. Now, the first question I have for you here, it says in 1962 in Pincher Creek, Alberta, a Chinook raised the temperature from negative 19 degrees to 22 degrees Celsius in 1 hour. This is actually a Canadian record. So the question I have for you is how many degrees was the temperature change? So I'll give you a chance to think about your answer. And another question I have for you here. How many degrees Celsius or how many degrees is the temperature change? I'll help you out a little bit here. Our temperature is at 20 degrees here, and then it's moved to 60 degrees here. So the question is, how many degrees is the temperature change? All right, so looking back at our first question here, we were asked how many degrees was the temperature change? Well, we went from negative 19 degrees to 22 degrees, and I'm suspecting that the way that you figured that out was to take 22 degrees Celsius and subtract negative 19 degrees Celsius, and you would have got 41 degrees Celsius. And if you're looking at this question, I'm suspecting that you probably went 60 degrees minus 20 degrees to get 40 degrees, and we'll assume that that's in Celsius as well. Okay. Well, this is sort of the basis or the starting point for absolute value. Well, let's take a look at the definition. So absolute value is the distance of a point from its origin. Now, you may have heard about absolute value before where you hear someone say it just makes the number positive. And really, when you look at it simplistically, that is the case. It does just make our value positive. But we need to look at where is absolute value coming from. So absolute value is the distance that a point is from the origin. So if I start at a point and I walk 5 kilometers east, I've walked 5 kilometers. If I start at an origin point and I walk 5 kilometers west, I may have gone in a different direction, but I've still walked 5 kilometers. And so in both cases, I'm 5 kilometers from the origin. So my absolute value would be 5 kilometers. Now, for those of you that are taking physics, you might make that connection between absolute value and magnitude. And so that's a word that we talk about in physics when we get into vectors and so on. Now, the symbol for absolute value is just some vertical lines, one on either side. So if I wanted to write absolute value of 2, I'd write the 2 and then up and down lines. So it's not a square bracket. There's no little ticks on either side. It's just 2 lines up and down. Now, the absolute value of C is written as absolute value C. And this is then defined as a piecewise function. Now, don't worry about the word piecewise. We're going to get into piecewise functions in another topic, but this is just sort of an introduction to it. So the absolute value of C, it's positive C if C is greater than or equal to 0, and it's negative C if C is less than 0. Now, again, we're going to get into that in a whole different lesson, so don't worry about piecewise functions at this point. Now, the absolute value of any number other than 0 is positive. So anytime that we take the absolute value of something, it's going to become positive. But a little bit more specific with that, I'm going to write this in here. If a number is positive, if it's positive or 0, then the absolute value is just that number. But if the number is negative, so we're talking about the number inside the absolute value brackets or absolute value signs. If the number is negative, then our absolute value is the opposite. All right, so let's take a look at some examples here. First, I have the absolute value of 4. Okay, well, the absolute value of 4 is just 4 because it's a positive number, so the absolute value is 4. Now the absolute value of 0 is just 0. Again, remember when we're talking about absolute value, we're talking about the distance from the origin. Now the next one here, we have -4. Well, based on our definition, if a number is negative, the absolute value is the opposite. So if I have -4, the opposite of that will be a -4, which is still going to give us that positive value. So the absolute value of -4 is a +4. And so if we take a look at a number line here, the absolute value can be used to represent the distance of a number from 0 on a real number line. So -4, negative is giving us the direction. So again, if we think back to physics, for those of you that are taking physics, that negative often gives us our direction. Did we move east or west or north or south? In this case, we're dealing with the x-axis, so it would be east or west. But the distance that we've moved, the total distance that we've moved is 4. And it doesn't matter whether we've moved 4 to the west or 4 to the east, the distance traveled is still 4. All right, so the absolute value of -4 is 4, and the absolute value of +4 is still 4. All right, so let's take a look at an example here. In this example, you're asked to compare and order the absolute value for these numbers. So you're asked to arrange the numbers in order from least to greatest. So what I'd like you to do is pause the video at this point and figure out what all of the values of your numbers are and then arrange them from least to greatest. And welcome back, guys. Let's take a look at how you did. So my assumption is that before you got started with the organizing of your numbers or the arranging of your numbers, you probably took a look at those negative absolute values and converted them into their positive counterparts. Now, one that you want to be careful of, right in the center there, we have that number -9. Notice there's no absolute value symbols, so that means it stays negative. Okay, we start seeing all of these absolute value symbols, then we start to make everything positive, but you have to be careful to check for those specific symbols. So I'll give you a minute there to take a look at the values I have and check to see if your answers match. Now let's take a quick look at how we would put an absolute value into our calculator. So if I wanted to type in the absolute value of -9, I would click on the math button. Then I would arrow over to number, and I would choose number 1 for ABS. And then I type in -9 and I close my brackets and I get 9. Now it's important to note that if you have a TI-84 Plus or any of the newer calculators, it's going to look much different on screen. With the TI-83 Plus, you see the ABS and the bracket. With the newer calculators, you'll actually see those absolute value symbols. So if I wanted to type in absolute value of -9, it would be the same process, math, and then over to num. And once you've typed in the -9, you probably have to arrow out to get out of those absolute value symbols. If I wanted to type in another one here, let's say I want to do the absolute value of 9/5, I would go math, over to num, absolute value 9/5, close my brackets. And it does give me the decimal. If you wanted it back as a fraction, you certainly could do that. All right. So that's how we would put absolute value into our calculator. Now let's take a look at the next piece. All right, when we're using order of operations, the absolute value bars mean the same thing as brackets. So when we start evaluating absolute value expressions, we need to treat those absolute value symbols like brackets. So everything inside the absolute value bars must be calculated first, and then the expression is written without the absolute value bars, and any other operations are done in proper algebraic order. In other words, we're following BEDMAS. You cannot use the distributive property with absolute value because everything has to be evaluated inside. Then once we know whether it's a positive or negative value within the absolute value or absolute value symbols, then we take the absolute value, then we can multiply everything else. So unlike brackets, we can't just multiply through or distribute through. All right, so let's take a look at some examples. So the first one here, we're asked to take the absolute value of -29. Well, if you remember from before, if the value inside the absolute values is negative, then we need to take the opposite. So this becomes a -29, which is a +29. Okay. Now I'm okay if you go straight from the -29 to the +29. I just don't want you to simplify it and go, oh, it just becomes positive. I want you to think about what that definition actually means. Now, if I take the absolute value of 12, this is a positive value, so that just becomes 12. if I'm taking the absolute value of 4 minus the absolute value of 6, I need to evaluate each of those individually. So the absolute value of 4 is 4, and the absolute value of 6 is 6. So 4 take away 6 is negative 2. So even though we're working with absolute values, we can still get a negative answer. It's only what's inside that absolute value symbol that gets changed, but after that, it's just regular operations. Now for the next one here, I have 4 minus 6. So that becomes 4 minus 6 is absolute value of negative 2, which then becomes a negative 2, and that's a positive 2. For our next example here, we have 5 minus 3 times 2 minus 7. And so that gives us 5 minus 3. Now we first have to evaluate the 2 minus 7, which is absolute value of negative 5. And then we have 5 minus 3 times a negative 5. Notice we have 3 negatives there. So 3 times 5 is 15, but because we've got the 3 negatives, this becomes 5 minus 15, which is negative 10. Again, notice we can get negative answers. 4 minus negative 7, or negative 4, absolute value of negative 4, minus the absolute value of negative 7. Well, the absolute value of negative 4, I'm going to simplify these a little bit now. Absolute value of negative 4 is 4, minus the absolute value of negative 7 is positive 7. Okay, now if you wanted to write write out the full steps here, that's like a negative 4 minus a negative 7, which becomes a positive 4 minus 7, which is negative 3. Now moving on to the next example here, if I have brackets within the absolute values, we're still following that process of BEDMAS. So I'm going to evaluate what's in the brackets first, and then multiply by the 2, and then take my absolute value. So this becomes 2 times 3 minus 8. So 3 minus 8 is negative 5, and that's still all absolute valued. So we have 2 times negative 5 is negative 10. Absolute value of that becomes a negative 10, which is 10. If I have negative 2 times 3 minus 7, that's going to be negative 2 times the absolute value of negative 4. So we have negative 2 times a negative 4, and 2 times a negative 4 becomes negative 8. Now taking a look at h here, we have an absolute value of negative 10 minus 2 times the absolute value of negative 3. Now we have this tendency to want to look at the negative 2 and the negative 3 and multiply them and say, oh, that's positive 6. But the absolute values, again, are different than brackets, so we can't just multiply through. We start off by evaluating our absolute values. So here I have a negative 10 minus 2 times a negative 3. So that gives me a positive 10 minus 2 times 3, which gives me 10 minus 6, which will be 4. Now for the third example here, I have negative 3 cubed, which is negative 27, minus 2 cubed, which is 8, and that's all absolute valued. And so that gives me negative 35, all in absolute values. And from there, we have a negative 35, which is equivalent to 35. Now, the last example we're going to look at on this page is writing expressions. So we're asked to write an expression to determine the distance between the following points on a number line. Now, in each of these cases, there's more than one answer. So we're asked to write an expression that shows the distance from negative 8 to positive 2. So if we're moving from negative 8 to positive 2, we can count that out and we can find out that the distance is 10. But how do we write that as an expression? Well, one way to do that is to take negative 8 and subtract 2 and take the absolute values of those. So negative 8 minus 2 becomes negative 10, all absolute valued, which is a negative 10, which is equivalent to 10. So again, we can count that out on our number line, but we can also write it as an absolute value expression. Now, the other way to do that is to subtract in reverse. So positive 2 minus a negative 8 would give me 10, and the absolute value of 10 is 10. So I think you've probably noticed that before on your calculator. If you accidentally, you're wanting to go 4 minus 3, you accidentally go 3 minus 4, you still know that the answer is 1. Okay, even though we've reversed our subtraction, we still know that the difference or the distance between those two numbers is 1. All right, so it's kind of similar when we're looking at these examples here. Now the next one here, we're asked to write an expression or an absolute value expression to show the distance from -2 to -7. Well, the distance from a -2 to a -7 doesn't change. And how we express that might look different, but we're still going to have the same distance between -7 and -2. And if you were to count that out, you would see that the distance is 5. So one way to write that out is the absolute value of -7 minus a -2. And -7 minus -2 is -5. We take the absolute value of that would be a -5, which gives us 5. Now the other way to write that out is -2 minus a -7. And if we take -2 minus a -7, that gives us 5, and the absolute value of 5 is 5. All right, now we don't have this example in your notes, but we're going to take a look at one more example. While traveling through an unfamiliar city, Shay and his friends proceeded to find the town's famous indoor trampoline park. They went back and forth, so back east and forth west, many times before finding the trampoline park. The question is, what was the total distance they traveled if the blocks they traveled are represented below? A positive number indicates east, and a negative number indicates west. Now, for some of you who are taking physics right now, you might start thinking about displacement. We're not talking about displacement. We're not talking about how far from the origin we end up. We're talking about the total distance traveled. So as these guys are looking for, or as these friends are looking for the trampoline park, they travel 3 blocks east because that's positive, and then 9 blocks west, 10 blocks east, and then 13 blocks west. So again, it doesn't matter what direction they're traveling, it just matters that they've traveled 3 blocks, 9 blocks, 10 blocks, and 13 blocks. So how do we represent that? Well, we're going to use absolute value. So they travel 3 blocks, then they travel another 9 blocks in a different direction, and then they travel another 10 blocks, and they travel another 13 blocks. So evaluating that, absolute value of 3 is just 3, plus a -9, plus 10, plus a -13. And so if we add that up, that gives us 3 plus 9 plus 10 plus 13. Well, 10 plus 13 is 23, plus 9 is 32, plus 3 is 35. So they've traveled a total of 35 blocks. That must be a really good trampoline park. All right, guys, so this is just a brief introduction to absolute value. You're going to be working with some absolute value expressions. In the next couple days here, we're going to start looking at absolute value functions, both linear and quadratic, and then we'll get into piecewise functions, and we'll finish off the unit with absolute value equations. So make sure if you're not understanding absolute value that you ask some questions, do some practice, and we'll see you soon.